Okay, welcome to today's lecture. Today's lecture is about chemical kinetics. Objectives. First and foremost, I'm going to teach you about the reaction rates. After that, I'm going to do an introduction to rate laws. After that, I'm going to teach you on how to determine the form of the rate law. And then after that, I'm going to teach you on the integrated rate law. And then after that, I'm going to teach you on the reaction mechanisms. And last, I'm going to teach you on the what? Catalyst. But for today, I'm going to concentrate on the what? Reaction what? Rates. But before I can define or teach you on the reaction rates, you need to know what chemical kinetics is. So what is chemical kinetics? So chemical kinetics is simply the study of reaction rates. Meaning this one just focuses on the changes in the concentrations of reactants and products with what? Time. So it just deals with the changes in the concentrations of reactants or products with what? Time. Note that it's not enough to understand the stoichiometry and the thermodynamics of a what? Reaction. We must also understand the factors that govern the rate of what? Reaction. And one of the main goals of studying chemical kinetics is to understand the steps by which a reaction what takes place, of which I'm going to teach you under the same what topic. So since chemical kinetics deals with reaction rates, you need to know what a reaction rate is. So what is a reaction rate? Okay, so reaction of rates. So what's a reaction rate? Reaction rate of a chemical reaction describes how quickly a chemical reaction takes place, or it just describes how fast a chemical reaction takes place, or in other words, it just describes how fast or quick the change in the concentration of reactants and products are changing over what time. Since reaction rate is involving change in the concentration of the reactants and change in the concentration of the products, it can be expressed as the concentration of the reactant consumed or the concentration of the product formed per unit what time. Note that the reactants in a chemical reaction are being used up, or they are being what consumed in order to form the concentration of the product per unit what time. Now that we know what the reaction rate is all about, you need to know the units for the reaction rate. So the units for reaction rates are moles per liter per unit what time, which can be written as mole per second, or mole per minute, or mole per what per hour. It depends like that. And then you can question yourself, why is it mole per liter per unit time? So you note that concentration, it can be measured in moles per liter. So sometimes the units can be like this. It can be mole per liter per seconds, like that, or it can be per minutes per hour, just like that. So note that this is concentration and this is the what the time, which is measured in, it can either be measured in seconds, hours, or what minutes. You need to take note of that. And then since you know what the reaction rate is, you know how to define it, and you know the units for the reaction rate, you need to know how to determine the reaction rate. So for the reaction rate to be determined, chemists should initiate a chemical what reaction. After that, chemists should measure the concentration of the reactants or the products at different times as the reaction what progresses. So this is what I'm talking about. So for you to measure the reaction rates, you need some chemists. So chemists should initiate the reaction. After that, chemists should measure the concentration of the reactant or product at different times as the reaction what progresses. So let's look at this part, this important part, and then you need to pay extra attention here so that you understand what's going on here. So this graph shows the change in the number of A and B molecules in a reaction as a function of time over 1 minute, period, bottom. So this graph shows the change in the number of A and B molecules in the reaction as a function of time over 1 minute period. So here I've been given A and B molecules. So A molecules are the one which are in what? Purple, and B molecules are the one which are in what? Green. So here let's come at initial before the reaction started. So before the reaction started here, we can observe that in this bucket here, which is at initial, the mixture here just contained purple molecules. And then as the reaction started, at 10 seconds here, we can observe that there was a change. We can see some green molecules which appeared in this bucket after 10 seconds. And then as the time progressed like that, we can observe that we are still losing purple molecules here. Purple molecules are decreasing, or they are disappearing. And then as time is progressing, moving like that, we can still see that we are still losing purple molecules, and these green molecules are being formed. And then at this time 60, at the end of this same time here, over the period of 1 minute, we can observe that we don't have any purple molecule in this bucket. So we can simply say that the purple molecules were, the concentration of purple molecules was decreasing with time, while the concentration of B molecules was increasing with time. So this is what's happening here. Note that reaction rate is the change in the concentration of the reactants conjunct, or concentration of the product formed per unit time. So this is what's happening here. Reactants are being consumed while the products are being formed. So A molecules are decreasing with time, while B molecules are increasing with time. So that's what you need to know here. Due to this, reaction rate can be expressed in terms of disappearance of the reactant or appearance of the product. As you have seen here, the molecules, the purple molecules in A were disappearing, while the green molecules were appearing. So here there is disappearing and appearing. You need to take note of that. So the reactants are disappearing while the products are appearing. So reaction rate can be expressed in terms of disappearance of the reactant or appearance of the product. So here you have reactant A, like that, which is being used or consumed to form product B, like that. And then since the concentration of A is decreasing with time, it's going to be negative, while the concentration of B is increasing with time, so that's going to be positive. So this one is decreasing, that's negative. This one is increasing, that's positive. And then we need to know that reaction rate is equal to the change in the concentration of either the reactant or the product over time. So reaction rate is equal to concentration of the reactant or the product over time, like that. Note that this can be written as rate is equal to change in the concentration of the product over change in time, like that, is equal to. So this one is for the product, where this delta means change, this square brackets means the concentration of B of the product over the time taken, over change in the time taken, is equal to. Now let's do for the reactant. So the reactant is decreasing, so we're going to say negative, like that. Negative change of concentration of A, reactant A, over change in time, like that. You need to know that. So where this one is just the negative, it's a slope, it's decreasing with time, so it's negative. So I'm sure you know where this negative is coming from. Where this is a delta, which means change, and then this square brackets means concentration of A over change in what? Time, like that. So you need to know this. This is very much what? Important. You need to know this formula. Very much what? Important. So let me try to show you so that you can understand fully on this. Okay, and I'm sure here you understand. Won't take much time here because whatever is here I've explained. So this is the reactant A, which is forming product what? B. So as I said, reactant A is decreasing with time, while product B is increasing with what? Time. So here it's saying concentration of reactant A, which is in purple, decreases with time, while the concentration of product B, which is in green, decreases with what? Time. So the concentrations of A and B are measured at time. It can be the time which is T1, which is the initial time, and the final time, which is T2. Respectively, we can have the initial reactant, which is A1, and we can have the final reactant, which is A2, like that. And we can have the initial product, which is B1, like that, and we can have the final product, which is B2, like that. So this is what you're supposed to know here. And then here, I'm sure you have a clear picture of whatever I was doing there. So with respect to the reactant A, let is equal to change in concentration of A over change in what? Time, is equal to negative. This negative, I'm sure you understand, because reactant A was decreasing with time, so there was that negative, so there is this negative here, is equal to, and then concentration, we have the final concentration here, which is A2, and the initial concentration, which is A1, and then down here we have the final concentration, which is T2, and the initial time is T1, is equal to negative change in A over change in T. I'm sure this thing I've explained and we are clear now. And then here, with respect to product B, let is equal to change in concentration of B over change in time. And then we can have the final concentration of B, which is B2, like here, and then we can have the initial concentration minus the initial concentration of B, which is B1 here, over the final time minus the initial time, like that. And this one is going to be positive because it was increasing with what? Time. All these things I've explained here, and I'm sure you're clear. Note that the negative sign is used because the concentration of A is decreasing with what? Time. So that's what you're supposed to know here, and I'm sure you're clear. Okay, so now let's look at the types of what? LEDs, which is very much what? Important. So we have this special type of LEDs called the initial LEDs. So what's the initial LEDs? Initial LEDs are LEDs which are measured at the beginning of the reaction, which is dependent on the initial concentrations of the what? Reactions. So these ones are measured at the beginning of the reaction just by the word itself, initial LEDs, and it's dependent on the initial concentrations of the what? Reactants. It's not dependent on the products, no, because you don't have products at the beginning of the what? Reaction. And then the other type of LED that I would like you to know is the instantaneous what? LEDs. So what is the instantaneous LEDs? So these are LEDs which are measured at any point during the what? Reaction. So instantaneous LED is measured at any point during the what? Reaction. And I'm going to show you how to come up with the instantaneous LED on the what? Graph, how you can obtain it, how you can determine the instantaneous what? LED. And then the other rate which you're supposed to know is the average what? Rates. So average rates, these are an overall rate measured over a period or time what? Interval. And I'm going to concentrate much on the average rates and the instantaneous what? Rates with some examples so that you can understand fully. So what's an average what? Rate? So average rate is the rate of a chemical reaction that is measured as the change of the concentration of reactants or the products during the whole time period of the progression of the chemical reaction. So this one involves measuring the change of the concentration of reactants and the products during the whole time period, meaning where it's starting and where it's ending. So this one involves the initial concentrations of the reactants and the products, and it also involves the initial time and the final time. So you need to take note of. So the average rate of change is given as rate is equal to negative. We have the reactant which is at T2, which is the final reactant, minus the initial reactant, which is at T1, over T2 minus T1. And then you can be asking yourself a question, why is this negative in front like this? Note that we use the minus sign before the ratio in the previous equation, in this equation, because rate is what? Positive. The average rate is what? Positive. So the reason why we are adding this negative, because from these two reactants you are seeing, in case you get a negative, you can multiply with this negative outside here so that it can give you a positive, because the average rate is a positive number, is not a negative number. So here you just have to know that we do not need the minus sign when calculating the average rates from the products. If you are not familiar with this formula, you can use this one. So average rate is equal to C2 minus C1 over T2 minus T1, like this. And then this one can give you a negative, but remember, average rate is a positive number. You're not supposed to get a negative number, it must be positive. So we do not need the minus sign when calculating the average rate. So therefore, that's the reason why they had to add this negative in front, in order to get rid of the negative that is going to come out from these calculations. So here what you do is, you need to know that rate is equal to negative change in the average rate. So here what you do is, you can use this formula. After finding the average rate, you need to put it inside here, you substitute, and then that negative you're going to get, mostly it gives the negative, and then you're going to multiply it with this negative so that you get a positive number, because the average rate is positive. So you need to take note of that, which is very much important. So yes, all these I've explained. Now let's do an example. So example 1, it's saying consider the following reaction at 300 degrees Celsius. So we are having nitrogen dioxide, which is decreasing with time, and we can see nitric oxide and oxygen gas is being formed. So the initial concentration of nitrogen dioxide is 0.0100 mole per liter, and its concentration after 150 seconds is 0.0055 mole per liter. What are the average rates of this reaction during the first 150 seconds and during the second 150 seconds if the concentration is 0.038 mole per liter? So solutions. So here let's come up with the average rate for the first one. So there are two questions here. The first one is saying the average rate of this reaction during the first 150 seconds. So here you need to come up with a formula. So average rate is equal to C2 minus C1. So these are the concentration over T2 minus T1. So what's your final concentration and what's your initial concentration? What's your final time and what's your initial time? That's what you need to know here. So your final concentration here is this one after the 150 seconds, which is 0.0055 mole per liter, like that. And then the initial it has been given, even the question is saying the concentration of nitrogen dioxide is 0.0100 mole per liter. So it has been given the initial 0.0100 mole per liter, like that. And then what's the time? T2, that's 150 seconds. The initial started at 0, like that. Then you just have to substitute now. Is equal to, so what's our C2? That's 0.0055 mole per liter minus 0.0100 mole per liter over, what's our T2? Our T2 is 150 seconds minus 0 seconds. So average rate is equal to, when you subtract that, what are you going to get? You're going to get negative 0.0045 mole per liter, like that, over 150, because 150 minus 0, that's 150, like that. Then here average rate is equal to, so what are you going to get here? So after dividing, we're going to get negative 3 times 10 to the power negative 5 mole per liter per seconds, like that. Now this is not the final answer. We said the average rate is not supposed to be what? Negative. It must be what? Positive, because it's a positive number. So what do? Note that this concentration of nitrogen dioxide is decreasing with time. So as it is decreasing, the rate will become what? Negative. So rate of nitrogen dioxide is decreasing with time. So there is change of what? Nitrogen what? Dioxide, like that, over change in what? Time. And then here will be rate is equal to negative, what's your concentration of nitrogen dioxide you had, or the average rate you have found here? It's the one that's going to substitute, which is negative 3 times 10 minus 5 mole per liter per seconds, like that. Then your final rate, average rate, is equal to, so negative and negative will cancel, therefore 3 times 10 to the power negative 5 mole per liter per seconds. That's the final what? Answer. Hope it's clear. And then let's do the other one so that you can understand now fully. I'm sure I agree on that one. So let's do for the other one. So this is how you find the average what? Rate, as simple as that. So let's do the other one, which is saying we need to calculate the average rate during the second 150 what? Seconds. So during the second 150 seconds, how can you find the average what? Rate. So let's do it now. Let's do it together. Then you can pause, and then you can pause the video and then try to solve on your own. You can pause and try to solve on your own. So here, what do? Okay, so here on the second question, what are you having? It's saying what is the average rate of the first, this one we have found, and during the second 150 watt seconds, if the concentration is what? 0.038 mole per watt liter. So another 150 seconds and the concentration has been given. So the concentration, that will be our second concentration, which is will be our final. After that 150, another 150 seconds, so it will be 0.0038, like that, mole per liter. And then our initial concentration would be this one which was after the first 150 what seconds, so it will be 0.0055 more per liter, like that. And then our time, final time, is 150 after another 150. So then the initial time is t1, like that, and then our initial time is what? 0. So let's use the same formula. So the average rate is equal to C2 minus C1 over T2 minus T1, like that. Then here, so average rate is equal to, what's your C2 there? That's 0.0038 more per liter minus 0.0055 more per liter. And then what's the second time? The T2 is 150 seconds minus 0 seconds. And then your average rate is equal to, you subtract these two, what are you going to get? So you're going to get 0.0017 more per liter, like that, over 150, like that. Then your average rate is equal to, after dividing there, you're going to obtain your rate as negative 1.1 times 10 to the power negative 5 more per liter per seconds, like that. And then this is not your final answer. This is not your final answer. What are you supposed to do? You need to ensure that your rate is what? Positive. How do you ensure that your rate is positive? Note that rate of this nitrogen dioxide is decreasing. So it's decreasing, that's negative. So there is change in the concentration of nitrogen dioxide over the change in what? Time. Or this is the same as the rate is equal to negative, then here you write the concentration of the nitrogen dioxide we are from finding, which is the rate we are having, minus 1.1 times 10 negative 5, like that, more per liter per seconds, like that. And then later on you're going to find your answer to be, that will be a positive, so it will be 1.1 times 10 to the power negative 5 more per liter per seconds, like that. Then you are done, just like that. So this one is very simple, and I'm sure you agree on this one. Okay, so let's go direct now to the instantaneous one. Okay, now let's look at the instantaneous rate. So instantaneous rate is the rate of a chemical reaction that is measured as the change of the concentration of reactants or the products during a known time period. So a known period or a time is given, and you need to take note that instantaneous rates can be rates measured at any point during the reaction. So time is given here, and then instantaneous rates can be determined by calculating the negative of the slope of the curve of the concentration of a reactant versus time. So you need to come up first with the negative slope on the curve. So instantaneous rate can be obtained on the graph. I'll show you on how you can obtain it. So since it's a curve, hence the slope of the tangent is equal to change in y over change in x. You know how to come up with this on your graph. you know your y-axis and your x-axis. So for the y-axis, it's just symbolizing the change in concentration. Then in the x-axis, that's the change in what? Time. So this is same as change in what? Concentration over change in what? Time. As simple as that. So this is what you're supposed to know. And note that also this instantaneous rate should be positive, not what? Negative. So you need to do what we were doing there. So since instantaneous rate should be positive, what are you going to do? The instantaneous rate must be positive, not negative. Same with the average what? Rate. You need to know that rate is equal to the negative change of the concentration. So over change in what? Time. I'm sure you're able to know where this negative is coming from, because this concentration is what? Decreasing with what? Time. So therefore, since this one is decreasing, I'm going to relate it or compare it with the what? The slope of the tangent what? Line. So a slope, you know how it is, decreases like that. So it's same as the what? The slope. So here you're going to say rate is equal to minus, here where there is concentration, you're going to write slope of the tangent line over time, like that. Once you're having this, then, and you know that the slope, it's decreasing, it's going to give you a negative. So that negative times this negative, you're going to get rid of the negative, and you're going to get a positive instantaneous what? Rate, because your answer is not supposed to be negative but positive. So that's how you go about this. Now let me show you an example so that you can understand fully. Okay, so this is what I'm from doing. We are saying instantaneous rates are measured at any point during a chemical reaction. So as you have seen here, there is this point here of time. So I don't know the time they gave there. So they can give you maybe 30, or they can give you 40 or 20. So in the time they give you, you come at the same time, you go straight direct to the curve, you mark there, and then you draw a what? A tangent. And then this tangent shouldn't cut the curve, but should be passing exactly at the what? Curve. And then you need to obtain your two concentrations just within this same tangent. So we're having the initial concentration there and the final concentration there. Our initial time and the final time was being what? Obtained. So therefore the slope looks like so. Slope is equal to the final concentration minus the initial over the final time minus the initial what? Time. So this is how you obtain the instantaneous what? Rate. It's on the graph like this one. So I'm sure you know how to go about this one, and I'm sure you are clear on how to find the what? The tangent. Yeah, the slope of the tangent of the curve. And I'm sure you know how to go about that one. Okay, now let's do an example so that you can understand fully. So nitrogen dioxide decomposes to nitric oxide and oxygen as follows. So here nitrogen dioxide is decreasing with time, while nitric oxide and oxygen are increasing with what? Time. Suppose in a particular experiment, we start with a flask of nitrogen dioxide at 300 degrees Celsius, and measure the concentrations of nitrogen dioxide, nitric oxide, and oxygen as the nitrogen dioxide decomposes. The results of this experiment are summarized in table, and the data are corrected. So at initial time, we had this concentration of nitrogen dioxide, while for the product, this was 0, 0, and then at 50 we had this, at 60 we had that, we had that, we had that, we had that. So this is the data that has been given to us. Now this is just the data, and the question is saying the table and the data are what plotted. So we need to know or to see the what the data. So this is the data for the table you are from seeing here, from seeing there, sorry. So as you can see, nitrogen dioxide is what decreasing with what time. As this same nitrogen dioxide is decreasing with time, nitric oxide, sorry, and oxygen are increasing with what time. Okay, now let's do an example so that you can understand fully. So nitrogen dioxide decomposes to nitric oxide and oxygen as follows. So nitrogen dioxide is decreasing with what time, while nitric oxide and oxygen are increasing with what time. Suppose in a particular experiment we start with a flask of nitrogen dioxide at 300 degrees Celsius and measure the concentrations of nitrogen dioxide, nitric oxide, and oxygen as the nitrogen decomposes. The results of this experiment are summarized in the table and the data are plotted. So this is a table at T0 at initial. The concentration of the reactant was 0.0100, and then for the products for nitric oxide was 0, for oxygen was 0, and then at 50 we had this concentration, for the products we had that, and for oxygen we had that, just like that. And then since this is a table and this thing is saying that the results of this experiment are summarized in the table and the data are what plotted. So this data was what plotted. So sometimes you can be given this data, they ask you to plot and later on determine the instantaneous what let. So you need to know that. Now in this case, this graph was being what plotted. So see what's happening here. This is a nitrogen dioxide is decreasing with what time. While this nitrogen dioxide is decreasing with time, oxygen and nitric oxide are increasing with what time. You need to know that. And then the question is saying calculate the average rate at which the concentration of nitrogen dioxide changes over the first 50 seconds of the reaction. So how can you find the average rate at which the concentration of nitrogen dioxide changes over the first 50 seconds of the reaction? So let's do it now. So solutions. How can you find now? So the question is asking us to find the average rate, and I'm sure you know the formula this time. So average rate is equal to C2 minus C1 over T2 minus T1, like that. Now the time has been given to be 50 seconds. So how can you know your concentrations here? How can you know your concentration? So because you need your final concentration and you need your initial concentration, you need your time, you also need your final time and the initial time. So what do you do there? So since the question is saying at 50 seconds, you need to go back to the table and so that you can be helped to determine the concentration there. So remember, this is the average rate. So here you are having 50. At 50, the concentration of nitrogen dioxide was what 0.079. Note that for it to be at 0, it started at initial. So at initial, that's time t. So we're having two times. This 0 is our initial time, and then this is our final time. This is our T2. And then here, this concentration here you are seeing here is the T2 is the final concentration of nitrogen dioxide, and the one which was at 0, this concentration at 0 is the initial. So we are having now two concentration and we are having two times here. So what are you going to do? Let's try to come up with the data and then substitute. So if you can remember, our concentration there at 50 was 0.0079 mole per liter, and then our initial concentration was 0.0100 mole per liter, and then the time is 50 seconds, and then the initial time 0 seconds. So let's substitute now. So average rate is equal to what's your final concentration, which was that 50, which is 0.0079 mole per liter minus 0.0100 mole per liter, like that, over what's your time, 50 seconds minus 0 seconds, like that. Therefore your average is equal to what is 0.0079 mole per liter minus 0.0100 mole per liter. So that one, when we, after subtracting these two, we're going to get negative 2.1 times 10 to the power negative 3 mole per liter over 50 minus 0, that's 50 seconds, like that. Therefore average speed is equal to, when we divide these two, we're going to get negative 4.2 times 10 to the power negative 5 mole per liter per seconds, like that. Now this is not the final answer. What are you supposed to do here? What you need to do here is, you know that the reaction for this equation is nitrogen dioxide, which is decreasing with time to form nitric oxide plus oxygen gas. Then you can also balance it like this. So this one is decreasing, therefore the rate of this is going to be negative, since it's decreasing, negative change of nitrogen dioxide over change in time. Therefore rate is equal to that minus the concentration of nitrogen dioxide, which are from solving, it's this one. So we can just substitute here now, which is which will be negative 4.2 times 10 to the power negative 5 mole per liter per seconds, like that. Therefore rate is equal to negative goes, so therefore it will be 4.2 times 10 to the power negative 5 mole per liter per seconds, like that. Then you're done. It should be positive, like that. Now let's solve for the instantaneous rate. How do you solve for the, now that we have found the average rate, let's find the instantaneous rate of reaction at 50 seconds. Sorry, this is not supposed to be 50 seconds, it's supposed to be 110 seconds solutions. So what you need to know is, first you need to determine the slope. So slope of the tangent is equal to change in y over change in x, like that. And then what you need to know is the concentration of nitrogen dioxide is decreasing with time. Therefore the rate is equal to negative change in nitrogen dioxide over change in time. And then here we're going to have rate, which is equal to negative, then negative the slope over time. Then the answer will be rate is equal to negative, what's your slope? So this slope, you're going to obtain it on the on the graph over the time has been given, which is 110 seconds. So at 110 seconds, we know. Now let's go to the graph in order to determine the y variable, which is the concentration. So here you come at 110. So this is 100. You come here you go up to the curve, and then this curve here, it's the one for nitrogen what dioxide. Don't forget that you obtain for the nitrogen what dioxide, not for nitric oxide or oxygen. So you come here, have you seen this is 110 seconds, so changing time, which is 110 seconds, and then the concentration here has already been obtained, so which is this one here, which is 0.0026, like this in the y-axis. So in the y-axis you're having this concentration, in the x you're having this time, which is 110 given. So this is how you obtain the instantaneous water rate. Now let's go here. So here we're going to say, since it's a slope, it's going to be negative 0.0026 mole per liter, like that. And then here what do? To be negative and negative will go. Therefore, your rate will be so what is 0.026 mole per liter divided by 110 seconds? So you're going to have positive of 4 times 10 to the power negative 5 mole per liter seconds, like that. Then you are done. Unless if you're having some questions, that's when you can contact me and let me know where you're facing the challenges. And then this is your question, which is in Toro sheet. You can solve it. You can plot the concentration time graph, and then you can calculate from the graph the average rate between 50 and 25 seconds. You can also calculate the instantaneous rate at 20 seconds and the initial instant rate. I'm sure this is very simple to you, and you can't fail to solve this, and because you have been given the graph and plotting is not a challenge to you. So the formula for the average rate, I've given you the instantaneous and the initial. Okay, and lastly, if you are interested, you can make some payments. You can pay. Each course is 100 kwacha for chemistry, physics, and mathematics. So thank you for watching, and have a good